Hello, my name is Taslum Murshid Rahim, ID 19115120089. Today, I will show you a healthcare dataset to predict stroke with classification algorithm. This project has two parts. The first one is I have implement in Python, and the second part will be this dataset will be implement in Weka. I have four group members in my group, and they are Riyaz, Tawhid, Tilak, and me. Riyaz and I have implemented this dataset in Python, and Tawhid and Tilak will be implement this in Weka. So at first, let's see the dataset first. Here is the dataset, and we have around maybe 4,000 row in this dataset, and we have to predict this stroke column from our dataset. So let's start with Colab. So at first I have import some library. This library will be used in our program. There is pandas and numpy, which will be used for data manipulation, and matplotlib for data visualization. In here I have import this dataset. I have already upload this dataset in here, and now I'm importing with pandas. Let's see how our dataset was distributed. Here we use info. We see there will be integer value, float value, and some string value. Then I have described our dataset. Here we see all the integer columns. We can see count, mean, and standard deviation in the all the nominal, all the numeric columns. Then we have print top 5 row from our dataset. We can see here there is some missing value in our dataset. So at first we have to handle these missing values. This code will say if there is any kind of missing value in numeric attribute. What I mean is numeric attribute is that we have to see in age, hypertension, then heart disease. These are all numeric value. So I have to see if there any kind of missing value in that column. So I use that. Let me see. Let me run some code from the beginning. Let's import, then info, then describe, then print the head. Okay, if we want to see if there are any missing value in age column, so there is no missing value in age column. If there is like if we have missing value in BMI, so if we say that we have missing value, we see we have missing value in BMI column. Okay. Now check if there is any kind of missing value in nominal attribute. Nominal attribute, what I mean is gender, then ever married, and work type, and smoke status, such like that. So we can see here in the smoke status we have missing value, that is none. So we have to handle these two column. First handle the BMI. We use mean value of that column and to fill the non value. So we use mean. We can see here in this non value was converted with the mean value. Then for the nominal data, I use mode value to replace all the non value or the missing value in smoking status. Now comes with the data visualization. Here we use Shelburne library for data visualization. What I'm doing is in that is set the style of that data visualization, then set the color of that, and we use count plot to visualize our data. What this graph mean is we have stroke 0 and 1. 0 means there is no possibility of having a stroke, and there is possibility of having a stroke by meaning 1. So we can see around 5,000 people have possibility of be have a risk of a stroke, and around 200 or 300 people have a risk of a stroke. This is the same data. This is the same visualization, but it's for the urban and rural people. We can see there are more urban people in that area in our data set than rural people. In here we use catplot to visualize that. In here we divided urban and rural, and then we divided male and female. Here we can see that in both of the cases, urban and rural, male have more possibility for a stroke than female. Then this is the same thing. It's for the ever merit. Here is the heat map of our data set. Basically I am showing the correlation between different attributes. We use heat map for this visualization. We can see there is a strong relationship between stroke and BMI, and we also see there is a strong relationship between BMI and heart disease. Here is the box plot to visualize stroke versus age. We can say that if the age was big, then there is a chance for there is a risk for stroke. We can see in here around if the age is 60 to 80, then there is a risk for a stroke. Now handling the nominal variable. Why I'm doing that? Because if we use algorithm, we can't use this string value because string value will not work in that algorithm. So we have to convert this string value into some numeric number or floating number. That's why in these columns, in these 5 columns, we have string value or nominal value. So I have converted this 5 column into dummy values. Here is the info. Now we can see all our columns are converted into some nominal into some numeric values. Here we can see our gender male is converted into zeros and 1, and all other nominal columns are converted into zeros and 1. Drop the ID column. What I'm meaning is drop this column because this is only about the ID of a patient, so it has no impact in our dataset. So I have to drop this column from our dataset. I have dropped this. Now we have to divide our dataset into train set and test set. That's why I have divided that, and I use 30% of test set, 30% of training set. Okay. Then we use decision tree algorithm. First we have to import decision tree classifier, then fit this classifier with X train and Y train. then we have to predict that classifier. Then for the classification report and confusion matrix, we have to import that. We can see the precision and recall about 0.95 or 0.96. This was good. This is the confusion matrix of decision tree. We visualize this with heat map, and this is the decision tree accuracy about 91%, and I hope this was good. And then I have import the random forest classifier. We use the classifier and fit that classifier with xtrain and ytrain. Then the same thing I have done, a classification report, and then here is the confusion matrix of random forest. This was the accuracy of random forest, about 94%. Now I have to scale my data. The question will arise why I am doing now, because we all know in decision tree was work in entropy and information gain, so there is no impact if we scale our data or not. That's the same thing in the random forest, because we all know random forest is divided the tree into many kind of sub decision tree. So this was the same. This also have no impact in scaling, but if we want to use support vector machine, we have to scale our data. That's why I have import standard scaler to scale my data. Here is the support vector machine algorithm. We use polykernel for our SVM, then predict the data. Then here is the confusion matrix of support vector machine. Here is the accuracy of SVM, around 94%. Now compare this three algorithm accuracy. We have used random forest, SVM, and decision tree. Just we compare this algorithm into this view. We can see that random forest and SVM both have 94% accuracy, and decision tree have 91% accuracy. So we can say that random forest and SVM works fine for our dataset. To visualize this, we just use matplotlib to visualize this graph. So that is all for today. Thank you so much for watching.